First, I would like to thank Mar Sobrel and Sarah Varela for inviting me to participate in this WISE symposium. It's a great honor to be here, and I'm grateful for the opportunity. My name is Joan Roughgarden, and I'm an ecologist and evolutionary biologist. I retired from Stanford about 10 years ago and moved to Hawaii, where I now live with my husband. We also got married 10 years ago, and moved here to start a new life together. So my career began with my graduate work at Harvard University. My advisor was Bill Bossert, and grad students with me included Monty Slatkin and Madhav Gadgil. And my thesis was on density-dependent natural selection, and this involved developing simultaneous equations for the gene pool and the population size of a population, and potentially could bring together population ecology with population genetics. I was a bit ambitious. And the main point to come out of that work was that it offered a population genetic foundation for the concepts of R and K selection that MacArthur and Levins had introduced earlier. MacArthur and Levins both stipulated that R was a measure of fitness in some cases and K a measure of fitness in other cases. And I pointed out that there was really only one concept of fitness. And by letting the fitnesses depend on population size and not merely being constants, then one could recover the concepts of R and K selection, but with a population genetic foundation. And after I finished my PhD, which was solely mathematical, I approached Ernest Williams in the Museum of Comparative Zoology. And his group included Tom Shaner and Bob Trivers. And Ernest Williams, as a herpetologist, was committed to the idea that the anoles of the Caribbean could be used as a natural laboratory for evolutionary processes. And he supported any student who had a problem that could be addressed using the anolis system. And so I was interested in the evolution of community structure, and I was interested in how natural selection could affect the competition coefficients and the predator-prey interaction coefficients, and that as a result of changing these interaction coefficients, the community structure as a whole would unfold. So I did that, and the reason I approached Ernest about working in his lab was that I felt that I couldn't get a job as a biologist with solely a mathematical thesis. At that time, Bob May had entered the field as a physicist, and Cy Levin was writing as a mathematician, and I felt the niche that I could fill would be to offer theory, the development of theory, together with fieldwork. And then after I left Harvard and moved to Stanford, I continued the work on anolis lizards for another 10 to 15 years, and key people with me included Steve Bacala, Roman Dial, and Sharoni Shafir. And together we worked on a lot of issues. Steve was particularly active in developing technology for detecting species interactions and showed that there was strong present-day competition between the anoles in the Lesser Antilles, and that the strength of the competition depended on the difference in body size. And Roman Dial was active in characterizing the community of anoles in the high canopy of rainforest in Puerto Rico. And Sharoni Shafir was able to demonstrate that anoles could learn. He was able to teach anoles to learn both how to detect, how to reveal different colors by their behavior, and also how to learn to forage optimally. So you could have an anole actually learning on the spot what an optimal foraging strategy is. Well, at the end of this work, we were being criticized on the proposition that the work wasn't very general. It was being conducted in the Caribbean, which was dismissed as a model system, and that the results wouldn't apply elsewhere. So I began work in the rocky intertidal zone off of California, focused specifically on barnacles. The reasons for selecting barnacles is that they're very abundant and very common worldwide. And so my thinking was that anything we found out about barnacles would be of value because barnacles themselves are inherently interesting and important. And if our results could generalize to other species, fine. But at least anything we found out about barnacles would be intrinsically valuable. Whereas we couldn't say the thing about anoles because it wasn't clear how important anoles were in ecosystems outside of the Lesser Antilles. That began about 10 to 15 years worth of work. That included Steve Gaines, Sean Connolly, and the theory development with Hugh Possingham and Joey Wassa. And our lab was focused on larval recruitment and what determines larval recruitment. And we introduced a new concept of the intertidal zone. And we envisioned that the rocky intertidal community was a two-compartment ecosystem, and that one compartment was the benthic compartment where the adults live, and the other compartment was the pelagic part, the offshore water column where the larvae occurred. And we argued that the dynamics in the water column side of the community were every bit as important as the dynamics in the benthic part of the community, such as competition and predation. And we did a lot of field work in ships and in matching sites along the entire California coast and up into Oregon. This work was my first encounter with doing something that was very controversial. In contrast, I must say, the work on anoles was very mainstream at the time, and it was easy to get funding. And in my view, the modeling wasn't particularly innovative because I was analyzing models that had been developed by MacArthur and Wilson based on the Locke-Volterra equations, and I was simply working in that tradition. Whereas for our marine work, we were introducing new models from scratch that implemented our idea of a two-compartment ecosystem, and or two-compartment community. And this was very controversial because Bob Payne and his group had long championed the intertidal community as a single compartment community, and they viewed recruitment fluctuation as a so-called stochastic factor and as a random influence that simply impinged upon what was basically a single compartment community. But our finding was that the recruitment, the processes that affected recruitment, including upwelling and various other currents, were every bit as important as the competition and predation. The upshot of this was that the basic principles that had been in the wind at the time of the intermediate disturbance principle and the keystone predator turned out to be special cases that occurred only in locations where there happened to be a high recruitment rate because of the nature of the offshore oceanography. And after this, I switched gears and worked on the synthesis of many studies about diversity in gender and sexuality, and that led to the book Evolution's Rainbow, which was very successful and has sold over 20,000 copies, maybe 20,000 by now, and is still selling, still very relevant. At the time the book came out, no one really knew or had a good sense of just how much diversity there was in gender and sexuality in different animals and across cultures as well. And I think my book has contributed to an increasing awareness of that. On the other hand, we also discovered that the explanatory framework for this diversity was very problematic and was based on Darwin's theory of sexual selection. And to explain the diversity, a lot of ad hoc additions and assumptions had to be made to the sexual selection theory, leading overall to a framework which is highly cumbersome, internally inconsistent in many places, and resembles in some ways a Ptolemaic theory of the solar system, and it's just going to collapse. And so I argued that sexual selection theory should just be scrapped and that we should start all over again. Well, after saying that, if you'll pardon the phrase, the shit hit the fan. There was just general outrage that I should say something so appalling. But time will tell. I think sexual selection theory is sooner or later going to collapse. And in the meantime, together with Priya Iyer and Era Ache, we developed an alternative explanatory framework that we termed social selection, and it offers accounts of sexual reproduction and sexual activity all the way from the origin of anisogamy to the structure of different family organizations. And this is all summarized in my book, The Genial Gene. The last stage of my career so far, I started about 5 years ago as a result of a conference in Israel, where I encountered the idea of the holobiont, a term introduced by Lynn Margulis, and the hologenome, a term introduced by Ilana Rosenberg. And this was enchanting. A holobiont is the union of a host with its microbiome, and a hologenome is the union of the host nuclear genes with all the genes from the microbes. And this was enchanting because we've all thought about a genome as a fairly static thing. I mean, an organism has a set number of chromosomes, a set number of loci on the chromosome, and it's populated by particular alleles at those loci. And that's it. That's what you're stuck with. And as an individual, that's what you've got to work with. On the other hand, a holobiont it has a dynamic genome because microbes can come in and leave, and it becomes a very fluid and expansive kind of genome. And so my most recent papers have been about how to put the idea of evolution with a hologenome on a firm population genetic foundation. Well, I know many of you have tuned in for more personal information and not just to hear me go on about my research over the years. And the elephant in the room is that I'm trans. And I don't talk about this much because it's quite painful. But I'm often asked about what it was like to be a scientist as a guy and how that differs from being a scientist as a woman. Well, first of all, two things about that. I transitioned over 20 years ago, so a lot of the experiences I had back then are pretty hazy now. And secondly, anyone who is trans doesn't experience the gender they're born into fully. So prior to transition, everyone who's trans has some kind of coping mechanism, and they experience the gender they're born into somewhat superficially. And so I can't really tell you how a guy fully embraces his identity and prospers or functions as a scientist. I can only tell you some of the superficial aspects of it. And what specifically? So I made a couple points here, which probably are relevant. The career track for a guy is very linear. It's like a train track. You get on at a station, and then you get off. You go to the next station, and then you go to the next one, and it's all pretty automatic. Whereas for a woman, you're getting obstacles placed in your way all the time. And so it's very hard to get from here to there as a woman because of these obstacles. And as a result, you'll see many women have a career track which is very nonlinear, and they had to take many detours and so forth in order to get ahead. A second issue involves authority. As a guy, you automatically have a sense of authority. You're endowed with a sense of authority. So if and I recall, if I had an idea or a proposition, it would be taken seriously. Whereas as a woman, it's very hard to get taken seriously. In order to get taken seriously, you often have to team up with a guy as an ally. And when a guy's willing to do that, you need to be very grateful. A related issue has to do with the motion, with your position within a discipline, whether it's central or peripheral. And I happened to transition in a year when someone named Ben Bears at Stanford, who's a trans man, was transitioning in the opposite direction. He was a neuroendocrinologist, and we had lunch together a few times to compare notes. And he would describe how when his early work done when he was living as a woman was not being taken seriously. And once he transitioned, then all of a sudden he shifted into a more central role within his discipline and received a lot of recognition. And I, if anything, have gone in the other direction, where I was centrally located and have moved to the periphery, in part, of course, because I'm convinced that sexual selection is a mistaken explanatory framework, and that's considered fringe by most behavioral ecologists. But that is my analysis of the situation. Thirdly is the concept of disciplinarity itself. Or actually, that's fourth. The disciplines are artificial. The disciplines are not natural. The disciplines don't emerge from nature. They're made by people. And I compare the allegiance to disciplines as, particularly by men, as analogous to mammals who go around and mark territories with their piss. And women just don't smell the piss. We just cross from one territory to another, i.e. from one discipline to another. And we're always being hammered for being too interdisciplinary, not disciplinarily grounded. And I interpret this really as a way of policing the territories. So we're constantly being shooed back into the territory as though we have accidentally trespassed or even knowingly trespassed into a neighbor's territory. And this is a real problem because I think that these disciplinary boundaries are primarily male constructs, and women are being asked to obey them, even when their work leads them elsewhere. Fifth, entirely other topic. There's a danger in fieldwork that women experience that men don't experience. Now, if you're working in Africa or South America, and a lot of the ecological and evolutionary action is taking place in the tropics, in places that are politically quite difficult. And not only that, they may have social norms which are problematic from our point of view. And you may be expected, they may be more misogynistic, and in any case, it's not necessarily safe for a guy to travel alone to do field work, because a guy can definitely be kidnapped or arrested or robbed or beaten and so on. But for women, there's in addition to those risks, there's the risk of being sexually assaulted. And I haven't done any field work since I transitioned, but I did participate in a bicycle trip in Vietnam, and I was just happily pedaling along, looking at the surrounding scenery as we were climbing a hill. And so most of the other cyclists had gone way out ahead of me, and I was at the back of the pack. And this guy on a motor scooter comes up next to me and forces me off the road, and was about to rape me. But I was able to get away and to pedal and walk to a nearby little shop along the side of the road, and he then zoomed away. And that left an impression with me, because at the time, of course, I was hot and sweaty, and there was no sense in which I was attractive, I would have thought, but it was my very vulnerability which was appealing. So I think the solution to this is always to go with a partner, like a diving buddy. And of course, it could be a local guide. It could be someone you trust, but I don't think you should do field work alone as a woman. And I'm not sure you should as a guy either, but certainly not as a woman. Well, they're the main things that come to mind. And then I would be remiss if I didn't emphasize the importance of family. I know a number of you are starting out with young families, and I think that's just great. And it's important to keep a work-family balance. And of course, it's easy not to do that because of the pressures of graduate school and then later as an assistant professor. But it's very important. And if you wind up getting tenure, then make doubly sure that you pay attention to your family. On the other hand, don't go 100% in the direction of family either, because sometimes families go south and you may find yourself needing to support your children by yourself and make a livelihood by yourself. So even though it's quite a slog, this whole career thing can be quite a slog, stay with it. It's very rewarding. Another thing, too, that you have going for you is that women tend to be really interested in the science itself, in the actual results, whereas guys often seem not to care what the actual science is. They're using their findings as a vehicle to rise in some sort of hierarchy, get higher on the totem pole. And I'm often astonished at how little interest male scientists have actually in the science itself compared to the fascination that we have in the science. So I think we're motivated to do the science for the best of reasons. Of course, probably some guys are going to get real pissed off at that, and there are guys interested in science, and there are manipulative women, I'm sure, but that still is my overall impression. So that's all I have to offer, and I hope this is helpful. I hope to have a chance to meet many of you at some time in the future, and best wishes for this wonderful WISE conference. Goodbye.